Hey everyone, my name is Michael and today I want to have a look at HotChocolate Fusion, our new solution for distributed GraphQL. In this episode we will look at the basics. So basically how to merge two simple graphs into one public schema that you want to expose. Before we get started, we are running workshops at multiple conferences throughout the year. So if you want to learn GraphQL from the backend to the front end, from HotChocolate to React, then join us for one of our workshops. If you like our content, please hit the like and subscribe button below the video. And with that, let's dive in. And today I'm gonna start with some slides. I usually start always with code, but just to get you into the concepts around distributed GraphQL. So when we talk about GraphQL, we typically have this monolith that serves for all our clients or for all our consumers really. When we talk about distributed GraphQL, we're talking about a GraphQL gateway that is constructed from multiple downstream GraphQL services. And in this context, we are calling them subgraphs. So we have a GraphQL gateway and multiple subgraphs that really make up our graph. And behind these subgraphs could be microservices or directly your database or whatever you have. Important is to reflect on why we want to have a distributed GraphQL setup in the first place. My recommendation is go with a monolith in the beginning or a modular monolith that is composed of multiple assemblies or whatever boundaries you like more. This is because distributed GraphQL setups are more complex because this gateway actually introduces network latency and stuff like that. But this is okay when you have the scale needs. So if we talk about scale here, there are really two factors of scale. One is that we want to have more people working on our graph. And if we have a monolith, it can become difficult or cumbersome. Maybe you have multiple teams in your company that work with different technologies like Node, C# or Java. Each of these teams can now use the GraphQL stack in their technology, and the GraphQL gateway will really compose these subgraphs into a public schema. The second scale aspect here is really that you can scale your various subgraphs independently of each other. Important here is to cut the graph at the right boundaries. So you want to have subgraphs that are owned by teams, and ideally they own the subgraph and the components behind your subgraph. By doing that, we really allow our teams to work independently of each other. I said we are using two subgraphs today to build a simple gateway here. In our case, we focus in on an account subgraph and a review subgraph. The account subgraph is all about the user data. In our example, we have a user type here that has a couple of data like ID, name, the birth date, and the actual username that we are using to log in. So typical account data here. Then we have the review service where users can write reviews about a product. In this domain, the team decided that the user is really the author. But in our overall graph, these two types are essentially the same thing. So what we want to do in our graph is really merge these two services or these two subgraphs and also semantically merge them. So we want to make the author and the user the same. If we look at the merged user type, for instance, we see that we have several fields. Some of them are overlapping, meaning they are in both subgraphs available. And this can help our execution engine to plan where to get the data most efficiently from. Other data are maybe only available on the account service or only available on the review service. Okay, enough of the words. Let's dive into some code. So I already prepared here our subgraphs. Let me walk you through. So this is a simple setup here. We have two subgraphs, as I said, the account subgraph and the review subgraph. If we look at the account subgraph, this is an Apollo server. We used version 4 here, and it's really a simple setup. I have here my schema file, and this has defined the types, like the user type. As I said, we have the user ID and name, birth date and username here. And we also have a query type, and we can fetch the user by certain aspects. The implementation is also quite simple. I have here a couple of resolvers that will fetch the user from my in-memory representation here, which is just an array in this case. But this could be a database. The second subgraph is the review subgraph here. And we have done that with HotChocolate. It's a basic setup where we have, let me walk you through, the query type here. And you can see we have a couple of data loader here. And the squiggles are because I haven't run my build yet. And this is using the source generator. But apart from that, we have a proper DB context that we use here. So there's a proper database, which is SQLite. And we have here the authors and the review. Okay, let's create the distributed GraphQL schemas from these subgraphs. So in order to do that, we start with some tooling that will help us in the build pipelines later. So HotChocolate Fusion is built so that everything can be done at build time. And that makes it very predictable when you deploy your gateway to production. But first things first, we're gonna install some tooling here to get started. Before we can install the tooling really, we need to create a tool manifest. So I'm doing a .NET new tool manifest. And that's basically like a package JSON, a registry of the tooling that we have in our repository. And doing it like that means that you have the correct matching tooling always in your repository. So when you build it in Azure DevOps, Circle CI, or whatever, you just do a .NET tool restore, and then you have all the tooling commands available there for Fusion. Okay, the next thing is we're going to install the tooling. In order to do that, we do .NET tool install and then Fusion command line. Okay, the tools are installed. The next thing we should do is install the templates of HotChocolate. So we have a gateway template. So in order to do that, we do a .NET new install and then HotChocolate templates. Okay, with the templates installed, you can see here, there's the HotChocolate GraphQL gateway template. We're going to use that. But before we're going to use that, let's have a look at our subgraphs and optimize them so we can merge them into one graph. So let me clear that. If we look at our subgraphs, we have the account subgraph, and the account subgraph already exposes here the schema. The schema we need to compose our gateway at build time. So there are a couple of other things around that we need. For instance, we kind of need an identifier for this subgraph. And we also need some configuration settings for this subgraph. We, for instance, need to know if we can do an HTTP connection to that subgraph, or if we do have to use WebSockets or whatever. So in order to configure that, we can use the tooling that I just installed to create a configuration that has these settings co-located with our service here. In order to do that, we use the .NET Fusion command line, and we have there a subgraph command. And in the subgraph command, we can use the config to set the HTTP connection to that subgraph. So this subgraph is running on port 4000. That could be different on production, but let's just keep it to the local deployment for now. So I'm just running that. And then you can see I get here a config, a subgraph config, which says this subgraph is called default, maybe not a good name. Let's call it account. And we have HTTP connection available on this route. So the GraphQL server is running on this route. We have to do the same for our .NET subgraph here. So I'm doing the same command, but in this instance, we are running on port 59092. And we are also running the GraphQL endpoint on the GraphQL route. So this created also the config here. We're calling this subgraph review. So these subgraph names here become important when you want to have different rules for directing data there. So configure different poly settings in your HTTP client factory and things like that. This is how you can address these subgraphs then. Okay, but with that, we have both subgraphs essentially basically configured. The one thing that is missing here is really the schema GraphQL, because this is a code first or an annotation-based GraphQL server where we infer really the GraphQL schema from the code. And we have built something into HotChocolate 13.1 and newer that lets you export the configuration without really running the server. So in this case, I'm just running the .NET run command. I want to run that for my project here. So this is a review subgraph. And here you can see the dash. And that means I'm passing now arguments into the project. And I can pass in here the schema export and say that I want to have the schema exported to the schema.graphql. And when I run this, you can see we get here just the schema GraphQL, and that we can use now to compose our graph. Just one thing, if you want to pipe the GraphQL schema into another command on your command line, then you also can do that and just leave the out parameter away. And then we will print out the schema into the console and you could pipe it to the next command line utility. With this, we can start really building our gateway. And to build our gateway, we're going to use our new template that we have. So I'm going to do a .NET new, and I'm selecting here the GraphQL gateway template, and I want to have that in the gateway directory. Okay, with that created, I can see the gateway is basically a single C# file. If I look at that, you can see we have here the HTTP client factory, but there's nothing configured to it because we are injecting the configuration from the subgraph configurations that we just created. And you could add here customizations like poly, and you also could create separate clients for each of your subgraphs that handle specific settings. Another thing that you might put into your gateway is a header forwarding. This is also standard ASP.NET Core. You basically forward headers to the clients that we create, and then they are passed down to the subgraphs. The really Fusion specific thing is just this single thing here where we say add Fusion gateway server. And then in this instance, we are using a local configuration file here to configure our gateway. We also configured it here to be hot reload. That means every time the gateway configuration is updated, the old public schema is phased out with all the requests that are currently running against it still completing, while already a new public schema is phased in and all the new requests going to that new schema. The second thing is we have here the transport configure. That is the same thing then in HotChocolate. Okay, we can just start this gateway. So I'm just doing a .NET run here. And this is just .NET run, not .NET watch. So I'm running that. And while it's running, I will update the configuration several times. And you will see that the gateway automatically has always the newest version. So while we're using here a file, you could have the configuration stored on Redis. You can store the configuration in our Banana Cake Pop services, and always the gateway is hot reloadable. So you deploy it once and you can configure it through this configuration. So let's start simple and just integrate the accounts subgraph into this thing. So in order to deploy a configuration to our GraphQL gateway, we have two steps. So when we talk about building your subgraph, and we didn't want all the configuration files flying around there. So we came up with a subgraph package, which is implementing the open packaging convention that Microsoft introduced for Word and Excel and also NuGet packages and things like that. And what we do is basically we build your subgraph, then we pack all these configuration into a single file that can be passed along between different pipelines if you choose to have multiple of these. So the first one is really the build pipeline that builds a subgraph very specific to that subgraph and then packs the configuration in a subgraph package. Here we really put in the environment specific configuration and also download the Fusion configuration. So the Fusion configuration really contains all the subgraph configurations plus the public exposed GraphQL schema. So with this in place, we can compose a new public schema, and we are doing that by taking the new subgraph configuration and composing it with the currently deployed configuration that we just downloaded. Once this is successful, we know there will be no error when we deploy that. So we can simply deploy our subgraph, and once this is successful, we deploy the new schema. So let's do that locally here. So the first thing I said is packing the subgraph. So I'm packing now the account subgraph, and I'm using the Fusion command line again, say subgraph, and then we pack the account subgraph here. And the next thing is we compose it against our gateway. So to compose it, I'm doing a Fusion compose and I'm targeting it to the accounts subgraph here. And in the accounts subgraph, you can see we now have this accounts FSP Fusion subgraph package. And when I run that, it's composed. My gateway now has a configuration. And as I said, my gateway is hot reloading. So I can just create a new tab here. And then we have a one-to-one composition. So basically we have all the resolvers here or all the types here that we had in our account service. So I can dive in here into the query type, fetch it by ID, and get all the data here. So let's do that, then run it. And then we get actually an error because we didn't start our subgraph. So let's do that. We go here to our accounts console, and then we're going to do an npm start. Okay, with that, my server is running, and we can go back to banana cake pop. We run that, and you can see here, now we have the stitched schema. There's a bit of overhead in the first request because Apollo had to initialize, but now it's fast. Okay, let's bring in the other schema, our review schema. So I'm going here to the CLI, and we basically do the same thing. First, we pack our subgraph. This time we take the reviews subgraph. With that, it's created. And then we do a .NET Fusion compose. This time we compose the reviews configuration into it, can go now to our banana cake pop instance, refresh it, and then we can see we composed here both schemas into each other. But there are a couple of issues here because we have now the author and the user, and they are basically two different types here. So you can see these are different types. I could query them. So I could go into that and go for reviews, and then for instance, or go for authors actually, go for authors and then get the name from the authors. And again, we didn't start our subgraph. So let me quickly do that. So our subgraph is up. We can go back to banana cake pop, rerun that, and you can see it's the same data. Okay, but what we want to do is really fold these types into each other. If your teams follow the same naming principles, we would fold them automatically and figure that all out for you. But in this instance, I specifically didn't do that. So I have different names, but I want to fold them still. So this is where really we put the federated concepts and the stitching concepts together and allow you to do such type folding. But everything is still distributed, right? Our configurations are distributed. So I can basically go here to my review subgraph and introduce a new GraphQL file. And you can have as many of these GraphQL files as you want there. You can structure this however you want. So in this instance, we are putting the schema and the extension file next to each other. And what I want to do is basically change the name of this author here and also of these resolvers. So what I can do is introduce here a schema extension, and then we are using a new concept that is in the current draft specification of GraphQL, which is called schema coordinates. So we can introduce here some refactoring directives. One is called rename, and we can specify a coordinate to a type system member. Each type system member has a single coordinate that can refer to it. So if I want to refer to the author, I just write author, and then I can specify the new name to be user. And I can do the same for the members that I have here. And then with the next compose, the system would take this into account and refactor my types. I could also remove things. There's a remove directive and things like that to reshape my graph. Okay, in this instance, I'm just running the commands again. So I'm packing my subgraph here. Then I'm composing my subgraph. And here you can really see I did a mistake. So it tries to merge these things. And that's what I mean. We have compile time security here. So if I miswrite my configuration and refactor something that doesn't match the signature of the other services, I immediately get here an error on the console, which is telling me that the types that I'm trying to merge here do not match the signature. And that is because I accidentally refactored both of these into the same name. So I'm fixing that now here, and then we can rerun that. And then the graph composes. So I didn't restart anything here. So it just doesn't run anymore because my schema has changed. There is no author anymore. And there is now a users here. You can see users, and these are folded into each other. So I have here users with all the properties I had on or with all fields I had on the account subgraph, but I also have now the fields here from the review subgraph. Let me show you one thing here. So we can now query into that and then get here the name of the user, but then also go for the reviews and the body here. So if I execute that, I just get my data here. But Fusion works here with query plans. So in order to look at the query plan, I can put in the GraphQL query plan header, rerun the query, and then look down here in the extensions and see there's my query plan. And you can see this is the original query I have, and it's written into this query plan. At the moment, it's a sequence, and you can see we are getting now the users not from the account subgraph, but from the review subgraph, because we determined that there is all the data on the review subgraph that we need to fulfill this request. Plus there is the reviews that we anyway have there. So Fusion will try to rewrite the queries into a query plan that fetches from the least possible downstream services. Let's optimize that a bit, because at the moment we would run into issues when we try to fetch certain things from both subgraphs. We kind of have to tell the gateway here a bit about the semantics of our schema. And I can do that in my extension file here. So I'm extending here the query type, and what I'm doing here is basically saying, oh, okay, this reviews by ID, the ID argument here is semantically the same as the ID on the type it returns. And by that, the gateway knows, okay, I can use that to fetch data from the reviews ID to patch data together in my query plan. I could do the same here for the author and also for this request. So this request is basically a batch request. So we can use that to batch these patches to this method. And that allows us to write very efficient resolvers. Okay, with this extension in place, we can recompose this. But let's also look at the second subgraph, and that's our account subgraph. And maybe we also do a similar optimization here and tell our GraphQL schema more about the semantics of the subgraph. So I did the same thing here to the account subgraph. I extended here the information, added some metadata to the user by ID field, and set the argument passed in here semantically equivalent to the ID field on the user type. So I'm composing also this. And then let's go back here to our schema. We can run that. It runs the same actually. But now let's, for instance, go here to the author or our user and fetch the birth date. And now this wouldn't execute anymore on a single graph, but on multiple. And if I do that, for me, it's basically the same thing here. You can see I get the birth date. But if I look at the execution plan, you can see that we are now fetching from multiple subgraphs. So first we go to the review subgraph. From the review subgraph, we are gonna fetch here the reviews and the username. And then we export for each user, that's actually an author on my subgraph here, the ID. And we are feeding that into the second request here. That is the accounts request. And we are feeding that into the user by ID field. Okay, that's a bit problematic actually. So we are doing a single request to the review subgraph, but then for each item, for each user, we are doing a request to the accounts graph. But we actually can optimize that. So we can go back to our account subgraph here and actually introduce a second field here, which we call users by ID. And this allows us to pass in multiple user IDs, and we get out multiple users. For each ID that we pass in, we get out one of these user objects. And I also annotated this field, and we can now recompose our schema here, go back to our GraphQL IDE, we run this thing, and we get an error because we forgot one thing here, and that is actually the resolver. So we also need to implement a resolver for this. So I'm going here into my TypeScript file, the index.ts, and we're going to introduce here a new resolver. Okay, so basically we get here multiple IDs in, we filter on our user array, and then we return the users that match to this IDs argument. So let's restart our subgraph, go back to our GraphQL IDE, we rerun that, and now it works again. If we go to our execution plan, you can see we still do the single resolve to our review subgraph, but then we do a resolve by key batch. We know now we can batch that thing, and that is better to do than using the single resolve. So basically we collect all the IDs that we get up here, and then we pass it into one batch down here and get it much faster. Okay, that was the first dive into Fusion. There is lots more. And actually, if you use like GraphQL enterprise patterns, like the relay pattern, we can infer all these annotations. There's also distributed subscriptions, differ and stream support, and these advanced GraphQL feature support that Fusion brings out of the box. In the next video, we will dive into the node pattern. And after that, we will look at mutations and subscriptions. So what do you think about Fusion? So give us some feedback in the comments. If you want to help our project, please go to GitHub and give us a GitHub star. This is the easiest way to contribute and help us to grow the project. With this, I'm out. See you next time.